2.2 billion pounds is how much we waste on unnecessary heating every year. We at Smart Heating would like to revolutionize the way we do achieve climate control.
Take this corridor for example. It is completely empty, yet it is still being heated. UCL heating is on since 8 AM to 6 PM, regardless of the occupancy of the areas. This leads to unnecessary wastage of energy. We can prevent this unnecessary energy wastage by turning off the heating when there is little to no one present in the corridors. We do so by integrating a system capable of keeping track of occupancy and temperature. And this is how it works. Our system uses two PIR sensors that track occupancy and one onboard temperature sensor that tracks temperature. The PIR sensors determine occupancy in the following way. When a person passes sensor A, it triggers its high state. If the sensor B is triggered as high afterwards, we know that someone entered the corridor. Conversely, when someone walks out of a corridor, sensor B is first triggered to its high state, following by sensor A being triggered to high as well.
We set up our system in Mallet Building as such. We place two PIR sensors to detect motion. These two PIR sensors are hooked up to a CC2200, which is an onboard temperature sensor. Here is a real-world demonstration of the system. As an individual walks past the sensor, the device will pick up the number of people in the hallway. Whenever someone enters the hallway, the number will increase by 1. However, when it's a group of individuals, the sensor will detect them as one and not as multiple people. Conversely, when someone leaves the hallway, the number of people in the hallway will decrease by 1.
The data from CC3200 are then passed onto the IBM Bluemix Node-RED editor through Wi-Fi chip embedded in the board. This application within IBM Bluemix enables us to quickly extract the important information from our JSON string via two different functions. The resulting output is a pair of occupancy and temperature measurements as seen in the output window. These measurements are then passed to the database set up through IBM Bluemix, where they are stored and accessed for further data analysis.
Once the data is sent to the cloud, we begin our first stages of data analytics. Firstly, the data is cleaned from potential missing values. Right now, this has not been a problem, however, cleaning is integral to obtaining a well-functioning system in case missing values do appear in the future. The data is then fed to a database which comprises of data from the same week as the data was taken from. The database is then split into temperature and occupancy data for separate analysis. In order to predict occupancy levels above or below the set threshold of 10, the occupancy data goes through a classifier that creates an additional row of binary observations based on whether the occupancy is above or below that threshold. This data is then fed through a K-NAND predictor algorithm with optimal K-value determined by cross-validation. For this example, the K-value is 9, as it shows least errors across the test data. This cross-validation procedure is repeated whenever a new day's worth of data is added into the database. Therefore, the optimal K-value makes use of added observations, improving its accuracy each week. To obtain heating latency, or the time taken to heat a room by 1 degree Celsius, the temperature of the data of the first hour each day is put through a linear regression analysis. Many factors could affect latency, and this is more practical to analyze this over a specific day rather than attempt to monitor a large range of variables with many sensors. In fact, over 3 consecutive days we already see a striking difference in the latency recorded. This information is fed back into the system, and coupled with the occupancy prediction, it allows the system to know when to turn on heating to guarantee a comfortable ambient when needed and minimize heating when not. A simulation of a full day's worth of data which the system was trialed on shows an average drop of around 20% on temperature, testament to the system's ability to reduce heating.